With that being said, let's get on with building some games. So I guess like some of you might recognize some of these titles that have become quite popular in the recent years, especially with the pandemic and everything. And there's just been a lot more various online games. But yeah, so games are interesting, and today we'll be building our very own web-based game. It will be multiplayer, like a lot of these. And one thing to kind of like think about that makes games different from a lot of the stuff we've been doing so far is, real-time games have a lot of very complicated game logic and game state. There's lots of things happening, people interacting with one another, doing various things at the same time, maybe at different times, and that can all affect kind of what happens. And as a result, it's quite important to keep in mind like how the game performs, like how your server is running, how your client is running, and just how quickly your code can actually run. Because if you're loading Chatbook or like loading Instagram, let's say, and maybe it takes an extra like half a second to load something, you don't really notice it at all. But if you're playing a game that's very high-paced, that you're doing a lot of actions with other people, half a second is actually a really, really long time, and it can get very frustrating for people playing the game. So this is just a little to keep in mind. We won't be thinking too hard about the performance, but we will talk a little bit about it later. So as a quick recap, for like what we've built so far, we have our user, which is on our client side, and that interacts with our server, which is the back end of our operation. We have our database, which is on MongoDB, and this is storing all of our like persistent data, anything that we need to like know for the future. We have authentication, which we use Google for. There are, I guess, other ways of doing that, but that's kind of what we've been doing. And the game logic and game state, so kind of like the brains of the operation, generally live on the back end, and we'll talk a little more about that as we go forward. And we'll use something called HTML5 Canvas, which is like a built-in feature to HTML, to actually draw the visuals of the game. So what exactly is Canvas? Canvas is an HTML tag, like an HTML element, similar to like things like the div, but it allows you to draw like essentially like a rectangle-shaped thing, and it draws it very, very quickly, and allows you to draw things like repeatedly, like constantly, over and over again. And if you do draw things like over and over again, like but adjust them slightly every time you draw them, you can get the effect of animation, kind of like what we're seeing here. And the reason why we use Canvas is that it is able to do this kind of update very quickly, as opposed to using something like React, which maybe will render once and then kind of just sit there. But Canvas is something that is meant to be kind of like constantly redrawing over and over again. One thing to note about Canvas is that unlike normal coordinates, the coordinate axes on Canvas are a little bit different. So just keep that in mind if you are ever working with Canvas. The x-axis is the same. It increases from left to right. But the y-axis is flipped, so it increases from top to bottom. And so the origin is in the top left corner of your screen or of your canvas, and then it kind of increases as you go to the bottom right. Awesome. OK, so one other review we want to kind of go over is with sockets. And because games have a lot of like real-time interaction that's very fast, we do want to have sockets in our game so that the clients can communicate with the game or with the server and vice versa. So we have a little short quiz, I think. So blank enables fast live communication between the server and client. Please say something. Yes, it's almost like it's in the title. I don't know why we did that. While blank E blank, blank, blank. The second, it's two words. The second word starts with E. Are for slow data communication. Do you have any ideas? The first word is 3 letters. Yes. Yes. OK, I should have put the things to display now, but that's fine. We use a blank socket to broadcast live updates to the clients. Any ideas? No? Server. And use a blank socket manager to receive updates from the server. So I said one of them. Do we have ideas for the other? Yes. Yes. And we'll go over the syntax a little bit. So the syntax to broadcast a message from the server to all connected clients. is socketmanager.getio.blank. Do you have any ideas? I think this was probably in yesterday's chat book. Okay, well, that's okay. We'll show the answers on the next slide. And the syntax of listen for the messages on the client. Yeah, let me just show the. So we use .emit to send messages from like one socket to another, which is in our case like kind of sending messages from the server to clients. And we are using socket.on to like kind of like open our ears and listen for any messages that might be coming in. Awesome. And today we'll be using sockets like bidirectionally. So we will have the client sending messages to the server and the server listening. We will also have the server sending messages to the client and the client listening. So we'll have kind of like both of these avenues. So what we'll be building today is a version of Agario, as you might have played like back in middle school or whatever. For those of you who don't know what that is, you feel free to go to weblab.mit.edu/example, and we actually have a tab that looks kind of like this. So we have like a game tab. If you log in and click spawn, you'll be able to like generate a little dude, and you can move around with, I think it's like WASD, right? Probably. Arrow keys. Oh, okay. Arrow keys. And then you can move around. You can like eat these like little like tiny pellets that will like make you bigger. And then you can also eat like other people who are smaller than you. And yeah. So that is what we will be building today. Yeah. Any questions so far? Or on any of the recap material as well? Okay. I guess we can continue. So how do we design a game like this? And for this part, I think we recommend that you close your laptop, actually. Like, so close the example, stop playing Agario, and follow along as we code, because we will be doing a lot of stuff, and there's like a lot of lines of code in this workshop, but you don't have to like follow along like line by line because it's like very involved. If you really want to, you can feel free to like kind of follow along, but generally I think it's best to like just watch and like go with how we're doing it. So we've developed all of this stuff for Catbook so far. We have, this is kind of like all of our React components. We have our app. We have all the different pages in our app. And then we have all our various components. And in the space of like kind of like the React design, we will not be adding very much. We'll only have like one new page, which will be the game page. And that will kind of like hold all of our game stuff. But behind the scenes, there is kind of a lot more going on. So just a little bit of context. We have like already made a bunch of components in React land. We have our client socket. We have our login. We have our server, which maybe has our server socket. And we're going to add a game component. We're going to add some input handling, like to do stuff when you press buttons on your keyboard. We're going to add a canvas manager, which will interact with like drawing things on the screen. And I'll be like drawing the canvas. And we have some game logic, which will be on the server, and that will kind of like hold all of the actual computation, like running the game. So when you press an input on your computer, it will send that information to the client socket, which will then like pass that via the socket to the server socket, and then the game logic will be able to like update itself and do whatever it needs to. And it will respond by sending that information back through the server socket to the client socket, and then to your game component, and then finally to the canvas manager, which will like draw the thing on the screen. We will go over that like in more detail in a little bit. So the general structure of Gamebook looks something like this. We have all the pieces that we just described. For now, we're going to ignore the login, the like other React components, and the other server files because we don't really need them. But we'll be focusing on the input, the client socket, the game like component itself, the canvas a lot because that is like the graphics of our game, and then like the API endpoint, server socket, and the game logic because that's like the server side of our game. And just to go over this one more time, when the user kind of like makes the input, like you click like the right arrow button on your computer, that will like be processed in your input file and send the information into the client socket, which will like pass it over to the server, and the server socket will like catch that like with the socket .on, and then like do things within the game logic file. And then once it's like done things, it sends the information back to the server socket and then to the client socket, and then that will be passed back into like your game and your canvas manager to like be drawn. Okay, so quick question. So we have an idea of game state when developing games. And game state is not the same thing as like the state of a React component. It's a more generalized term that refers to just the information and kind of like all the things you need to know about the game to like properly say like what exactly is going on. And so game state might include things like, for our case, like who's playing the game, like all the people who are logged in, maybe the location of everyone who's playing, like you need to know like where the different like cells are. You need to know like the color or like what the image is of each person, and like how big they are, like where the food is, like maybe who won the game, etc. And there like might be some more information in here, but generally it's like this is the kind of information that like fully determines what the game is like doing at any point in time. And so this is what we call the game state. And the game state generally lives on the server, so in kind of like your game logic area. And that's because you don't want your client to be able to like directly interact with all the stuff in the game. Like you need one kind of core, like true state of the game, and the different clients will like read that state, but they don't necessarily like have the ability to like manipulate it themselves. So, you know, in this way, like you don't have problems with like people being desynced in different like times and stuff like that. So the game state is always on the server, and that information will then be like saved and then like passed over to the client, and the client will tend to take whatever parts of the information they need to actually draw like, you know, the visual game from that game state. And one last thing we want to talk about is there's two general ways to communicate between the client and the server. We have mentioned both of them. So the first is sockets, which is like a live, fast way to just like communicate back and forth rapidly. And then we also have our API requests, or HTTP requests, that are like generally a little bit slower, but you can send like a lot more data and have a lot more like versatility in how we handle them. So typically we'll be using APIs for things that like don't need speed, like setting up the game, like starting a game, maybe like resetting the game, etc. But sockets will be used for like the actual stuff that's going on in the game itself. Okay, so now I think I'll give it off to Kenny.
All right. All right. Let me know if you have any, if you can't see like anything during the workshop. It's the first time I'm trying this, but there are basically 3 screens I want to share, and I had to find a way to make that happen. So that means putting 2 screens on 1 screen. So I'm going to say the most important part is a code. Second most important part is this diagram on the right, and then the slides are just like an accessory, just to give you the overall picture of each step. But I think you'll mainly want to pay attention to the code and the slides over there. Sorry, not slides, the diagrams on both screens. Hopefully the diagram is not too small. Let me know if it's too small, though. All right. Cool. Yeah, so let's start live coding this game. Again, like Nick said, I suggest that you guys don't check out the code on your own computer, actually. Instead, you should pay attention to the screen and the diagram just to see how someone might code a game. And maybe later on, you can review it by yourself and sort of like port over some of the code into your own repo as well. So only if you want to follow along, you can check out W8 Starter and follow along, but I would suggest not to. OK. So this is how we're going to break down a game or game making today. You can choose to do it however you want in your own projects, but we thought this would be the most intuitive way to present it to you guys. So we have 6 steps today. The first step will be creating our game page and routing Catbook to our game page. So basically what you guys have done many times before, just make a new game page on the navbar and make like an empty game page. Step 1 will be to add some basic game logic and introduce a canvas display to our game page. So just have like the screen that you play the game on. Step 2 will be allowing user input with their keyboard. So connecting your arrow keys to like inputs on the front end. Steps 3 and 4 will be core game logic. And then step 5 will be adding respawning and some win conditions to our game, so to complete our game finally. All right, any questions about what we're gonna do today, like the individual steps? Okay, cool. Yeah, so let's start with step 0, making our front-end game page. Yeah, so like I said, we previously made this catbook. We previously made catbook without any game page on our navbar, but all we want to do is add a game page right here. So I am going to follow these steps. I can see the code snippets. All right, so this is only modifying front-end code because we're just adding our game page. But the relevant files here are going to be this game.jsx file that we handily added for you guys, index.jsx, which provides our routes to all of our pages, and navbar.jsx, which has like basically just all the links to our navbar. All right, so step 0.1, I'm going to import the game component into index.jsx. So we've done this many times before, but import game from components, and then I think it's pages, and then game. Right. So import our game, and then 0.2, let's route the game page to our DOM. So that will be creating a route similar to chatbook, profile, and feed. I'm just going to copy and paste that and put in game right here, and change the route to /game. And then finally, in step 0.3, we want to add the game page link to our navbar. So again, literally just copying and pasting. We can do the same thing, route to game, and say that the title of our page will be game. All right, and now if I go to our local host, I think it would be better if I do that. Yes, if I go to our local host now and sign in, actually, I actually don't have to sign in for this, but and I go to our game page, it's literally just an empty page now, as expected. Okay, any questions about step 0? We just made a page. Okay, awesome. We'll get to some of the harder parts now. Actually, before I move on, I wanted to start drawing a bit about like what we're going to do today. So I think following this diagram will be helpful because there's a lot of intricacies between like different things on the front end and the back end. I think this is the most like connections we've done between the front end and back end in all of WebLab. So I think this diagram might be a bit helpful. So I'm going to start drawing on this diagram. So today, I'm just going to say that we have like 3 different things that I want to showcase. Let's say that our objects, any objects that I consider important are going to be in red. Any functions that I consider important are going to be in blue. And then like any like client-server interactions. I see. Okay, that is unfortunate. Yeah, that's true. Okay. Is this okay? Actually, maybe I can. Yeah, I think I'll just do this, and then I'll write bigger on this iPad. Okay, so any client-server connections will be in purple. So this includes our sockets and API connections. Okay, and then I'm going to separate this screen into the client and the server because those 2 things can't naturally connect unless they go through our client-server connections, which are in purple. And as you guys have learned before, in the middle of these 2 client and servers, or sorry, in the middle of the client and the server, we have API land. which allows the client and the server to interact through predetermined routes. Okay, so any questions about the initial design we have here? Okay, so I'm just going to draw like circles for each of the things we have on the client and the server. So hopefully it'll make it more clear which files we're editing as well. So these correspond to like the file names I'm going to edit. So on the client, we have something called the Canvas Manager. So we've defined the Canvas Manager to contain all the utility functions for drawing and stuff on the front end, just to group them together. And then we also have the game page, which is the page we just created in step 0. We have an input file, which has helper functions to process any keyboard inputs that we put in. And then finally, we have a client socket file, which manages all the sockets on our client side. And then I'm also just going to draw here like our keyboards or our arrow keys, because that's what we're going to ultimately use to input stuff into our into the game. Okay, and then moving on to the server side, we actually just have 2 things that I want to showcase today, which I'm going to draw here. So the 2 main files that we're going to edit are game logic, which contains, like the name says, like all of the game logic for our game, and then server socket, which manages the sockets on our server. Oops. And these 2 files, game logic and server socket, are going to interact in many different ways to provide like a cohesive view of our game. Okay, so any questions about the main setup of our of Catbook right now? Okay, cool. So if I go to the code here, you can see these files on the sidebar as well. Here in the pages, we have game, and then on the front end, we also have the Canvas Manager, the client socket, and input. Sorry, input is somewhere. Oh, right, it's not in step 0, but input will also be on the front end. And then on the server side, we have a server socket, and we're also going to make a game logic file in a future step. Okay, any questions about our code and our design, like where they connect? Okay, cool. So let's move on to step 1. Okay, so step 1 is going to be, as mentioned before, adding some basic game logic. So we're going to populate this file over here, and then being able to display some things on our canvas. So that's going to be here and connect it to here. Okay. So one thing to note is there's like a new React hook that I want to introduce you guys to, which is useRef. Basically, what useRef does is it gives the front end the ability to reference objects on the page without the objects like explicitly like giving their own like own objects to manage. I didn't explain that well, but basically for our canvas, we're going to render it sort of like using like a HTML tag, like open tag canvas, like close tag, and there's no way to reference that once we render it unless we pass in like a reference to that HTML tag. Then we can use that in the rest of our code to update our canvas periodically. So useRef basically just allows us to update our canvas and also display our canvas at the same time. Okay, I'll skip this slide, but I will break down the substeps as I code. Here. Yes, check out step 1. Okay. All right. So there are a lot of to-dos in this step, and they're spread across different files. Oops. It might seem like daunting, but I will lead you guys through it, and then draw stuff on the diagram, and hopefully it'll become more helpful. Okay, so in the first step, we're just going to initialize the game state on the server. So Nick described before that every game has to have some sort of game state, and that lives in the server side, which is the ground truth. So step 1.1, we're going to initialize this game state and actually start the game on our server. And then we're also going to send some game updates to our client. So what this is going to look like is here on the diagram, we're going to initialize this object called GameState. And we're going to have, let's just say, like a winner and a players array at first. And then we're going to have this function called updateGameState, which will namely just update our game state as we go along. And as we make our game, we're actually going to add more logic to this updateGameState function to actually keep updating our game. And also in step 1.1, we're going to introduce this function called startRunningGame in our server socket. And that's going to run at 60 ticks per second. So this is constantly running in the background. OK, so let's start coding this up. Yes. OK, so I'm going to close all these front-end code tabs, and then going to go to game logic and server socket. So in game logic, the first thing we're going to do is just create a game state object. Literally just an object in JavaScript that for now we'll say contains a winner, which is null because we don't have a winner when the game starts, obviously. And then players, which is an empty array because we just don't have any players at the start either. Oh, const game state, you're right. Sorry, actually players will, I guess it can be either an object or an array, but I'm just going to initialize it to an object first. OK, and then later on, we're going to create this function that I just mentioned, which is updateGameState. And let's just leave that as an empty function. And then finally, we want to be able to export these functions to use them in our server socket. So let me just add our game state and our updateGameState function to our exports. OK. And then there are some things we want to do in the server socket, which in the diagram, I drew a start running game. So the server socket is going to manage how many times our game updates per second. So I'm going to define a function here that first sends a game state to all of our clients. So that's going to be, actually, sorry, I'll do this in a bit. But the first thing I want to do is just create a function that makes our game loop, which is updating the game many times per second. So that's the start running game function that I mentioned. And then basically JavaScript, I don't know if you've seen this before, but there's this set interval function, which allows us to do things at a regular interval. So I'm just going to say that we're going to use this updateGameState function that we imported from the game logic file. And then we're also going to send GameState to the client, which we're going to define in a bit. OK, I'm not actually going to run this, so there might be some syntax issues. But basically, this is going to be the setup. Yes. And then we're going to do 60 ticks per second. So because there are 1,000 milliseconds in 1 second, 1,000 over 60 means that there's going to be 60 ticks per second of our game processing. So this is our game loop. It's literally just calling an update to our game state and sending the game state over to the client every 60 times per second. And then here, we actually want to like send the game using sockets to our client. So we're going to do io.emit and update, game logic, and game state. So basically, we're just going to send our game state to our client. OK, so what that looks like, if you head over to the diagram, is basically we just define like a helper function to send our game state over. And we actually define our socket with the channel update, which will eventually connect to the client. Okay. And then finally, the last thing we want to do in this step is just call the function above to start the game. So when the file is initialized, it'll just simply start the game. OK, any questions about 1.1? Yeah, I know that was a lot, but I think other steps will be not spread across like a lot of different files.
Quick thing about set interval. So the syntax for set interval has like, it's basically do all the stuff in the set interval every blank amount of time. And so every like 1,000 divided by 60 like milliseconds, we call the inside of set interval. So that's why it's 1,000 divided by 60. It's in milliseconds.
Yes. All right. So in 1.2, we're just going to define like some basic game logic, like the step is. So we're going to basically have like a spawn player function and a remove player function in our game logic file, which will allow us to easily call these functions to spawn players and remove players when players join the game and leave the game. So in our spawn player function, we're just going to add like something to our game state, namely a player. So given a player ID, let's just say that a player has three different things. A position, which is we have this handy function called getRandomPosition to initialize a position to a random space in our canvas. Our radius, which will have a constant initial radius. And then finally a color, which I'm just going to hardcode to red for now. But when you're actually making your game, you probably want to have like different colors and different sprites. And what you can do is you can like sort of like predefine an array and like choose a random color from this array, et cetera, when you actually spawn your player in. So what that looks like is now we have this function here that allows us to spawn a player. OK, and then step 1.3 is basically the same thing, except remove player. I'm not going to do that now. Actually, I will do that now because it's just one line. But we can just delete the player from our array. Sorry, from our object. OK, does anyone have any questions about spawn and remove player? I know that was a bit fast. OK, so following the same trend, we have remove player in our diagram here as one of the functions in game logic. All right. I think because this is probably going to take a longer time than I thought. I think what we're going to do is like I'm going to show you the code instead of like coding it live and see where I would have put in stuff like if I was coding live. So I don't have to like type out things manually and make it longer than it needs to be. So I'm actually going to check out step 2 and go to like where step 1.4 would have been. Okay, so in step 1.4, what we were going to do is we're going to call spawn player whenever the user connected to server like via the website. So what this means is in here, in server socket, this add user function, remember from yesterday's lecture, this add user function is called whenever the client connects to the server. So here we can just add in the spawn player function, which will just spawn a player directly into the website. For now, we're just going to assume that whenever the player connects to the website, it just spawns in. We're going to fix that later, but that will, yeah, it will basically just spawn the player in whenever a client connects to the website. And then in 1.5, we're going to process updates from the server in the client. So we're going to head over to our front-end code, and here in game.jsx, we see this process update function. And what we can do is we can call this draw canvas function, which comes from our canvas manager, to actually start processing updates. So let me show you what that looks like in our diagram. So actually, I'll show you in the code as well. In our canvas manager, we have this thing called draw canvas, which has all the utility functions to fill in our canvas, because our canvas is literally just like a blank, I guess like a blank square that we can draw anything in. So you can see we have this fill style, fill erect, and we're drawing the players here as well. So what that looks like here is in the diagram, we have this draw canvas function. And what we just did is we called it in game through process update. Right? Does that make sense to everyone? So Canvas Manager is actually the thing that draws our game. And in game page, we're calling process update. OK. And then we can also add this utility here, which will update the game periodically. So you guys are familiar with useEffect, but basically whenever this mounts, we're going to turn on a socket with the channel update that will basically, every time it receives an update from the server, it will call this process update function that we just defined. So what that looks like in the diagram is we turned on the socket, and that will give, that will call process update every time it receives an update. And we have our first connection from the server to the client because we connected these two sockets with the same name. So we have that beautiful connection there. So you can start to see some sort of path being formed. I use my laser pointer here. We have this start running game, right, which runs process update doesn't run process update, but it runs update game state 60 times per second, and then it passes it to the socket here on the update channel, which passes updates to the client, which processes updates and draws a canvas here ultimately. Okay, so this will be one of the main paths that we go through in this game here. Okay, any questions about this path? All right, and then finally, the last step in this, last sub-step in this step is just simply being able to draw players on the canvas. So what we did was we just defined this function here called draw player, which will be called every time draw canvas is called. Yeah, right here. Oops. Okay. Yeah. All right. So I think moving forward, probably the most important part is looking at the diagram. So I'll let you guys look at that screen for the most part. The code will just be me showing you, pointing you to things in the code that you can refer back to if you go back to this workshop, or when you actually want to code up your game, maybe things that you want to add for your game explicitly. But for now, let's move on to the next step. So like in the overview, step 2 will just be being able to read and process inputs from our keyboard. So that's all going to be on like the client side. So as a nutshell, like this is what we're going to add to our game. When we move when we like press down on our arrow keys, what the game is going to do is going to like move the sprite like up, down, left, and right. Okay. So the first thing that I want to do is send the move data from like the server, from the client to the server, and have the server like listen for move data. Basically, we have this connection now, right, that has like our start running game sending updates from the server to the client, but we want to find a way to have our client send updates to the server through client inputs, right? So let's start to form that path. So what we're going to do is in client socket, we're going to create a new socket with the name or with the channel like move, which will just like emit events that are moving, or sorry, emit move events from the client to the server. So let's check out step 3. And in client socket, as you can see here, we just export our, we just emit any move messages from the client. I think that would be helpful, yeah. Okay, and then our, in step 2.1 as well, we also want to have the server listen for these move events. So what we do in server socket is add this new socket called move as well. And it'll be socket.on instead of socket.emit because server is listening for updates. So what that'll look like is simply the client will just send messages to the server like that. Okay. Any questions about adding a socket? Yeah, Nick is adding right now like our move socket. Okay, so step 2.1 was just initializing the socket on both the client and the server. All right. Now in step 2.2, we actually want to handle like our keyboard inputs on the client. So if you're making a game, obviously you want like some sort of interaction with the user. So let's just say in our game, the up, down, left, and right will like, do stuff. So in input.js, which is this file over here, what we can do is add a new handle input function, which will simply call on the move client socket here. So any inputs that are handled in this input helper function will just call the client socket. Yes. Okay. And then in step 2.3, this is a continuation of like this handle input function we just did. But we actually want to listen for the keyboard inputs and stop listening when the user leaves the page. And what we do is we introduce this thing called event listeners. So if we go to the game page here, we have this new object called event listener. Actually, it's not called event listener, but I'll just say it's an object called event listener that will listen for any like events that we specify. So in this case, we want to specify like when we press down like the up arrow, the down arrow, the left arrow, and the right arrow, and that's called key down in like JavaScript land. So we're going to add this event listener whenever we mount the page for game, and then call this handle input function when a key down or when one of our keys is pressed. So what that looks like is here, if you look at the diagram over there, the arrow keys are going to activate the event listener, and the event listener is going to activate the handle input function.
Also, for event listeners, like we mentioned key down as being like a word that you can use to like detect when a key is being like start pressing down. There are other types of events that you can listen for. You can all like find them online. For example, you can be like key release. There's like down and up, which is like press, I think, or something like that. And there's like all kinds of other like mouse movement and stuff that you can all detect. And there's like all the documentation is online. So if you want to like listen for any other things that you're doing with your keyboard or like with your mouse or even like a touch screen, you can do that too. Those are all online. But yeah, key down is like an actual keyword here.
Yeah. So hopefully now you guys can see a little bit about like the new path that we're forming on our diagram. So now we have our keyboard inputs, right? And then any key down like goes to our event listener, which goes to this handle input function, which activates the move socket, which emits a message to the server. And now the server is able to listen for any moves on the client side. So we have our initial path here, and then our client to server path here now. Okay, any questions about our new code? All right. And now, finally, we just want to, on the server side, let's like actually, once we receive like move messages from the client, let's actually like change the game state. So in steps 2.4 and 2.5, Nick is going to like handle receiving messages from the client on this move channel. Yeah, I will let him do that. But essentially on the diagram, what this will look like is move will go all the way over here and call this update game state function, which will ultimately update our game state here. And then now our path is complete because once the move socket is activated, it'll update our game state. And this is the ground truth of our game. OK, any questions about our new client to server path? OK, so yeah, Nick is still handling the it's like a lot of if statements, but we need like 4 different things to handle, right? Like an up key, down key, right key, and left key. So we're just going to change the position of the player in the game state according to these 4 cardinal directions. Now, if we actually run the thing, I wonder if it will work. So remember, we added the client to the game whenever we logged in. So let me try logging in. Right, so we spawned in. And now if something is wrong, but when we press the arrow keys, our sprite or our circle should actually move. But it's OK. We don't have to debug now, because I think we just move on. Oh, yeah. That's OK. Yeah. All right. Let's check out step 3. Probably don't. Yes. All right. Sorry. Let's move on to step 3. You just have to type it out. Yeah. OK. Do you mind changing the slide as well? I think it's the other way. Yes. OK. So step 3 is going to be our core game logic. So what we're going to do is, like in Agario, we just want to be able to have the player like eat food. So let's implement that in our core game logic here. So that'll all be on the server side over here. OK, do you want to go to the next slide? Oh, it's the other way. Yeah, OK, yes. Skip to the, yes, because I think it shows hidden slides when you like, yeah. OK, awesome. So a lot of steps here, but I'm going to break it down for you actually before we get started. So in 3.1, we're gonna like change our game state and actually add food to our game, and then spawn in the food whenever our game starts. 3.2, we're going to basically define a function to check if any players can eat food. And 3.3, we're actually going to call that function in our update game state. And then in 3.4, we're going to check to see if there are enough foods in the game, and then spawn in any foods if there are not enough. So all of this lives in like the game logic file because we're just going to basically just keep checking to see if there's food, if players have eaten food, etc., and modify our game state as needed. So 3.1, again, we're just going to define like a new function called spawn food. So Nick is going to code that up. What that'll do is we're just going to like push a food object to our food array in our game state. And I might mention that we actually added this food array here to our game state. Yeah, basically what Nick is doing is just choosing a random color from our colors list. You don't have to like be that fancy. Okay, and then in the next thing we're going to do is we will actually want to draw foods on the canvas. So on this client side over here on the diagram, we're going to add this function called draw food. Sorry, it won't be called draw food, but it'll like draw food. We're actually calling it draw circle because food is just a circle here. And this function will be called every time like draw canvas is called. So we already have everything in place, but every time we make updates to our canvas, we're going to draw food as well. Okay. And then the next thing we want to do is we're actually going to define like more functions on the game logic side to check to see if players can eat food. So remember here we had our like game loop that runs 60 ticks per second. And this calls, actually I didn't draw this in, but this start running game will actually also call the update game state function, like this. So this game is running 60 ticks per second, right? And what it'll do is it'll update the game state like 60 times per second as well. So what we can do is we can add functions in this update game state function that'll be called 60 times per second to process any updates in our game that we need to do. So what Nick is going to do is he's going to add this compute players eat food function. And the function has a lot of words, but essentially what this function is going to do is it's going to check to see if a player can eat a food, whether the player object is like overlapping with the food object. Then it will like remove the food from the game and make the player grow bigger. Okay, any questions about what we just did with like adding compute players eat food to our update game state function? Okay, cool. And we actually want to remove the food from the game whenever the player eats the food. So let's just define a function here called remove food, which Nick just did, and have compute player eat food, actually call that function whenever food is removed. So now there's this like server path, you can think of it. We're going to start running our game here. That's going to call the update game state function. And that's going to call the compute players eat food function. And then if the player meets a condition, it's going to call remove food here. And you'll see later that all of these functions actually will just update the game state. So I'll draw that in as well, including remove food. So remove food is ultimately going to update our game state here. OK, and then the next thing we're going to do is actually make sure that there's enough food in our game. So we can define a function here called check enough foods, which will basically count the number of foods in our game and then spawn in more foods if there aren't any. So that's just going to call this function here, spawn food. OK, any questions about step 3? Yeah, so like Nick coded the entire thing up, which is great. So now like when we move around, we're going to start eating food. And then if the conditions are met, the game logic will remove the food from the game, update the game state. Actually, can someone tell me like why, I guess like what is happening that allows these checks to occur? Like what is happening in the background that allows like the checking if enough food, checking if players can eat food, etc. Like on the server side. I guess like open hands if you think that it's like the sockets telling like the server. Yeah, open hands if you think it's the sockets telling the server to update its game state, and close hands if you think that it's the game loop that's running 60 times per second that tells the server to update the game state. OK, you guys get it. Nice. It is a game loop that checks every 60 times per second any checks that are necessary to update the game state. All right. So we can skip step 4. Because step 4 is another core game logic step, but it's basically the same thing as step 3, except we're going to have players attempting to eat players. But it's not really necessary for the core understanding of how to make a game. So if you have time later, feel free to go through it, but we're just going to skip the step and go to step 5 now. Yeah, I can keep doing it. OK, awesome. Yeah, so step 5 is going to like be adding finishing touches to our game. Now that we have like, we can actually say that we have a game, but we're gonna have to add like win conditions and respawning. So there are 2 ways to communicate between the client and the server, which are sockets and APIs, as we've seen here. And in this step, we're actually gonna introduce like how like APIs and sockets, like you can use them at the same time to make updates to your game. So if you move on to the next slide. Yeah, so one thing that we want to do, instead of like spawning a player in as soon as it joins the website, we want to add a spawn button to our game page to actually let the player, like when they click the button, it'll tell the server to update the game state and spawn the player in. So yeah, we're going to have the spawn button live in the game. You can go to the next slide. We're going to have the spawn button live in this game page, and then ultimately send a message through API land to the server to update the game state here. And I'll actually draw that out now while Nick like starts to implement stuff. OK, so just a little bit of setup before we actually like spawn players in using this button. Yeah, if you remember previously, like we spawned the player as soon as like the player joined the website, but now we want to like define this function called add user to the game, which will spawn the player and then remove user from game, which will remove the player. So I'll add that to our service socket here. And like Nick just coded up, these functions will call the spawn player and the remove player functions. So now this helper function here will call spawn player, which will update the game state. The remove user from game will call remove player and update the game state here. OK. And the next thing we want to do is add API endpoints to actually use these like add user to game and remove user from game functions. So if you see the diagram, we're actually going to add this like /spawn endpoint and the /despawn endpoint. And these are going to call add user to game and remove user from game. So now if you look at the code, the spawn endpoint is going to add user to game, and then despawn is going to remove user from game. Awesome. And then now what we want to do is add a spawn button, like mentioned before, in our game page. So if you look at the diagram now, let's add a spawn button, which I'm going to say is an object. And like in React, we can call API endpoints easily. So we're going to just have the spawn button call the spawn endpoint. So now if you look at the code, the spawn button is just going to send a post request to the spawn endpoint. OK, so sorry for making you switch views a lot, but if you go to the diagram now, we have made a new path from the client to the server. So anytime the client calls or presses the spawn button, now it's going to call our API endpoint /spawn, which will add user to game, spawn player, and ultimately update our game state here. OK, any questions about adding in the spawn button? Yeah, so spawn in. It's OK. OK. And then the next thing we want to do is sort of a more code intricacy thing. But we just want to make sure to clean up our player whenever our socket disconnects and whenever we leave the game page. So what that'll look like, if you look at the diagram, is every time the event listener disconnects, we're actually going to call the despawn endpoint. Plus, every time the component disconnects, we're also going to call the despawn endpoint. So what that looks like is, now we have this new connection between the event listener and despawn, and from the game page itself to the despawn endpoint. So under these two conditions, we're going to call the despawn endpoint. And then we're going to explain a bit later why it's really important to despawn your player on these two conditions. Yeah, so now in the event listener, in the return callback, we have to call this despawn endpoint, which will despawn our player. OK. And then finally, our last step, we want to add a win condition, right? So we don't want our player to keep growing infinitely, like you saw in the previous demo. We want to actually have the player win when it's big enough. So if you look at the display, it's okay. If you look at the iPad screen sharing over there, we have to add this check win function, which will be called every time the game state is updated. And what that'll do is it'll just like check to see if the player is big enough. If so, then it'll just win. And the amazing thing is that we don't explicitly have to make a new path from our server to our client when a player wins. And can anyone tell me why? Actually, you can just think about it for like 15 seconds. Like, why do we not have to like make a completely new path for like checking our win condition? Well, we actually already have a path here from our games, from our start running game that goes through our update socket, right? That processes update on the client and then draws our canvas on the client side. So actually, this check win function here, we don't explicitly have to connect it to anything because it's already connected through our update game state function. Does that sort of make sense to everyone? Okay, awesome. And then finally, the last thing we want to do is actually just have a winner modal or like a winner pop-up on the game page to make it a bit more fun. So I'm going to add that object to our game page. So I just wrote winner modal on the iPad. And what that'll do is from process update, if there's a winner, we're just going to display the winner modal like, as such. All right. Now, if we demo the code that we just wrote, hopefully, when we spawn in, we actually have the player spawn. We can grow in size. And theoretically, if we get big enough, then we should have a win condition displayed. I wonder if we'll get big enough in time. Are you increasing the number of food that we have? Yay, OK, so now our winner modal appears, and we actually don't keep growing infinitely. OK, let's go back to the slides real quick. Actually, we can like center the slide screen now, probably. Yes. You double click on the, OK, awesome. And then all right. So do you want to explain that?
Oh, yeah. One interesting thing that you might have noticed that we did is that we explicitly call a bunch of like cleanup stuff, like remove user from game, etc., when the client disconnects or when the socket disconnects or like for whatever reason. And there's kind of like, you technically don't need it for the game to run. It does work without it, but this is actually like quite important. And so one of the things that can happen when you have these kind of like games that people can connect and disconnect from is that when a client joins the game, like the server will spawn that player in, you know, like make that little circle, and maybe some more clients will join, spawn a bunch of more circles. And at some point, like people might just like disconnect or leave the game or for whatever reason. And those like player circles will like remain there until you get rid of them. And usually that's kind of not what you want in a game. Like imagine you're playing like a game of chess and 3 moves in, your opponent like disconnects because their Wi-Fi is bad, and you have to sit there and wait for like 10 minutes to like know that they're not there anymore. So like a lot of the time, like you do want to actually get rid of like people who have disconnected for whatever reason. And the way that you do that is you just like take all of the parts of the game state that are like associated with that player and like delete them, get rid of them for whatever reason. And for our purposes, that's like we delete the player out of the players array. We can like remove like all of their data. And we do that whenever either the socket disconnects or when the player like moves to a different page. So like the component dismounts, and that generally covers most of it, but there can be other like situations that you might want to cover.
Yes. All right. So I think that might have been confusing for a lot of you, but there's a lot of like intricacies that go into like creating this game, which is why we have such a complicated diagram. And I guess like the diagram is something new we tried this year because I think the code, looking at the code, it's like hard to connect different things. But hopefully on this diagram, once we recap, you'll get sort of like a better sense of like what components you need to like add to your game. Sorry, what components you need to add to your game in order to actually make set your game up for success. And then like later on, you can actually like look at the code, what we wrote for each of these parts, to like concretely see what you need to add. So I wanted to go through like 5 different paths that we just created for our game. And likely, if you make your own game, you'll have to like add all of these paths actually. So the first path is having keyboard inputs. So if you look at the iPad over there, one of the first paths we introduced was this keyboard input. We'll activate the event listener on the game page, which will call this handle input function, which will call the socket emit function on the client, which will send a message to the server across the move channel. And then finally, the server, with that message, will update the game state. So that's the first path that we made. The second and third paths that we made are with the game ticker. So this is on the server side. We start with this start running game on, if you look at the iPad over there, the start running game. And that will call update game state, which will update the game state right here. So that's on the server side. And then the third path is going to start from start running game, send game state, and then it'll call on socket.emit on the server side, send a message through the update channel to the client, and the client will listen for that and draw on the canvas. Does everyone see like where those 2 paths start from start running game here? Okay, path 4 is going to be our spawning player button, which originates from the front end and goes to the back end. So we added the spawn button like object over here, which will call this API endpoint to do /spawn, which will add user to the game on the server socket, and call spawn player, which ultimately updates the game state. And then finally, the last path that we introduced was whenever there's like a socket disconnect or event listener disconnect, which just means like the game page was unmounted. So that originates from our event listener here and goes down to /despawn endpoint, which removes user for game, calls remove player, and then finally updates our game state here. So if you take away anything from this lecture, the one big trend that I wanted to mention is that everything ultimately updates this game state object. The game state object is your ground truth on the server. So any updates that you make from the client that you want to see propagated in your game, any updates that you make on the server that you want to see propagated in the game have to update the game state here. And then the rest of these paths are just being able to render the game and being able to have the client like communicate to the server. Yes, game state is updated in every path. So awesome. And then you guys completed a gamebook. It's always, every year, it's always like the most complicated lecture because it like puts together so many different things that you've learned. But hopefully you've gotten something away from this lecture, even though it's complicated. I'll post this diagram up later so you can see it. Hopefully it'll be a bit more helpful when you go over the lecture.
So if you did not like fully understand everything that was going on, because there was just a ton of content, feel free to just use the game book lecture and like the workshop code in your own projects. A lot of this is meant to be kind of like a reference for if you are making a game or anything that kind of involves a lot of live rendering, maybe like some of that like game logic concept. So you can use that. You can look at the code like later on your own time or like ask questions in office hours. But I think it is like it's a really helpful resource. So do use that. If you want to see the final product, you can git reset-hard, check out like WA complete. It will have all the stuff that we did here. There's a little bit more that we added. So like we put like sprites instead of colors. So we have like some pictures on the circles. We actually added some boundaries to the map. Originally, we didn't have like a way to like stop at the end of the screen. So we added that. There's a little bit of like auto resetting on the server and some extra styling. So feel free to like poke around in the code and see like how some of that is done. Yeah, I mean, we can do this, but also we are a little bit out of time, so I'll just give you the answer. Yeah, so sockets, very useful. They enable all the live fast communication. API endpoints are like for the slower, like more methodical, like larger things. We use Canvas to actually draw the game. Event listeners let us, kind of like see what's going on like with your keyboard and mouse and then like use that information. And then all the game logic lives on the server. The game state is stored in that like game logic file. That's kind of like the ground truth of what's happening in the game. And then we, like when a component dismounts or when a socket disconnects, we want to like clean up all the stuff that's in the game. But yeah, so that is all for Gamebook, I believe. Do this part.
Can we just get a quick round of applause for Kenny and Nick? All right, everyone, please open up feedback. Take 1 minute to fill that out before we go to lunch. We really would appreciate your feedback on this lecture, particularly because the format is different than all the other workshops we've been doing. Like, what do you think of live coding with them explaining with the diagram? Was it very helpful? Was it really hard to pay attention? Whatever your thoughts are, please let us know so we can figure out the best way to run this workshop in the future. So take 1 minute for feedback.